Langchain Azure Dynamic Sessions Tools Summary. This section provides a comprehensive overview of the langchain Azure Dynamic Sessions tools. These tools facilitate the creation and management of dynamic sessions within the Azure environment. By leveraging the capabilities of langchain, these tools empower intelligent interactions within these sessions. Inputs. This represents the information provided by the user during a session. For instance, it could be a question, a command, or a request for specific data. The session context encompasses all relevant information gathered and accumulated throughout a session. This includes previous user inputs, system responses, and any relevant context retrieved from external sources. Outputs. This refers to the responses generated by the system in response to user queries. These responses may encompass answers to questions, execution results of commands, or relevant data retrieved based on the user's input. This represents the updated session context after processing user input. This updated context incorporates the new information obtained during the interaction, ensuring a consistent and coherent session experience. Steps. The first step involves receiving user input from the user interface or communication channel. This input serves as the trigger for the session processing and response generation. The relevant context associated with the current session is loaded. This context might be retrieved from persistent storage, cached memory, or other sources. The received user input is processed, analyzed, and interpreted to understand its meaning and intent. This might involve natural language processing techniques, parsing, and data extraction. Based on the processed input and the loaded context, a relevant response is generated. This response might be a textual answer, a piece of code, a retrieved data point, or a combination of these elements. The session context is updated to incorporate the new information gained from the user input and the generated response. This updated context will be used for subsequent interactions within the same session. The generated response is returned to the user through the appropriate interface or communication channel, completing the interaction cycle. Prerequisites. An Azure subscription is required to access and utilize Azure services, including the Azure OpenAI service. This subscription provides access to the necessary resources and compute power for running Pay. Langchain Azure Dynamic Sessions Tools. Langchain is a powerful framework that facilitates building and deploying applications with language models. The langchain installation is essential for utilizing the langchain components within the Azure Dynamic Sessions tools. The Azure SDK for Python provides the necessary tools and libraries to interact with Azure services from Python code. This SDK enables the integration of the langchain Azure Dynamic Sessions tools with the Azure environment. Fine-tune parameters. These parameters control the behavior and performance of the underlying language model used for generating responses. Fine-tuning allows you to adapt the model to your specific needs and domain by providing additional training data and adjusting model settings. These settings control how sessions are managed and configured. This includes options such as session timeout, storage mechanism for session data, and access control policies. Challenges and fixes. Maintaining the consistency and accuracy of session state across multiple interactions can be challenging. To address this challenge, consider using persistent storage mechanisms to store session data. This ensures that the session context is preserved even when the application restarts or the user resumes the session later. Users may express their intentions in various ways, using different phrasing and language styles. Employing natural language processing (NLP) techniques can help mitigate this challenge. NLP algorithms can analyze user input to extract the underlying meaning and intent, regardless of the specific wording used. Langchain Azure Dynamic Sessions Tools Summary. This document outlines the key components, steps, and considerations for building a dynamic session-based chatbot application using langchain in Azure OpenAI Service. It highlights the core functionality, prerequisites, and potential challenges, providing a roadmap for developers seeking to leverage this powerful combination for natural language processing NLP tasks. Inputs: the unique URL address of your Azure OpenAI service deployment. This endpoint acts as the gateway to access the chosen language model within your Azure environment. Think of it like a web address for your AI model, allowing your application to communicate with it. For example, you might have an endpoint like https://yourresourcename.openai.azure.com. A unique authentication key generated by Azure for your OpenAI service deployment. This key is essential for securely accessing your deployed model and preventing unauthorized access. Think of it as a password to access the model, ensuring that only your application can interact with it. Outputs: a comprehensive record of all interactions between the user and the chatbot, including both user prompts and the chatbot's responses. This history is valuable for understanding the conversation flow, identifying patterns, and improving the chatbot's behavior over time. Imagine it as a transcript of the entire conversation, preserving the chronological order of every exchange. The chatbot's final response to a user's prompt, meticulously formatted to be both informative and user-friendly. This output represents the core outcome of the chatbot's processing, providing the user with a clear and organized answer or solution. Think of it as the polished final product of the conversation, delivered in a way that is easy for the user to understand. Steps: initializing the Azure OpenAI service is crucial for establishing a connection with your language model. This involves setting up the necessary credentials, such as the API key and endpoint, to enable communication between your application and the Azure OpenAI service. Think of it as the initial handshake before starting a conversation, ensuring that your application can successfully connect to the language model. The creation of a langchain session is critical for managing the flow of conversations. This session serves as a central hub for handling user prompts, retrieving relevant data, and generating responses. It acts as a conductor, orchestrating the entire conversation and ensuring a smooth interaction between the user and the chatbot. Processing a user query is the heart of the chatbot's functionality. When the user enters a prompt, the chatbot needs to understand its meaning, extract key information, and formulate a relevant response. Think of it as the chatbot listening intently to the user's request and actively trying to decipher its intent. Storing the chat history is essential for maintaining context and enhancing the chatbot's ability to respond meaningfully. By keeping track of previous interactions, the chatbot can learn from past conversations and provide more accurate and personalized responses. Think of it as the chatbot's memory, allowing it to recall past interactions and use that knowledge to improve its performance. Returning a formatted response involves crafting a clear and concise output for the user. This output should be well structured, easy to understand, and appropriate for the context of the conversation. Think of it as the chatbot presenting its findings in a way that is comprehensible and valuable to the user. Prerequisites: an active Azure subscription is necessary to access and utilize the Azure OpenAI service. It provides the platform and resources needed to deploy and manage your AI models. Think of it as the foundation upon which your chatbot application will be built. A deployed Azure OpenAI service is crucial for using the service within your application. This involves selecting a suitable language model, e.g., GPT-3, configuring its parameters, and deploying it to Azure. Think of it as the actual AI model that will power your chatbot. Langchain, a powerful Python library specifically designed for building and integrating language models into applications, is required. It streamlines the process of interacting with AI models and helps you manage the conversational flow. Think of it as the toolbox that provides all the tools you need to build and customize your chatbot. A properly configured Python environment is essential for running your langchain application. This includes installing the necessary Python libraries and setting up any specific environment variables or dependencies. Think of it as the workspace where your chatbot application will reside. Fine-tune parameters. The specific language model, e.g., GPT-3, codecs you choose to use within your Azure OpenAI service deployment. Different models have different strengths and capabilities, so selecting the right one for your application is crucial. Think of it as choosing the right tool for the job, ensuring that your model is well suited to your chatbot's intended purpose. The temperature parameter controls the randomness of the model's responses. A higher temperature value will result in more creative and unpredictable outputs, while a lower value will produce more consistent and predictable responses. Think of it as a dial that adjusts the level of creativity and originality in the chatbot's responses. Challenges and fixes. An incorrect Azure API key can prevent your application from successfully connecting to the Azure OpenAI service. To resolve this, ensure that the API key you are using is valid and matches the one associated with your deployed service. Think of it as double-checking your password to ensure it is correct. Verify that the API key is entered accurately and that it is associated with the correct Azure OpenAI service deployment. An invalid Azure OpenAI endpoint URL will also prevent your application from connecting to the service. To fix this, confirm that the endpoint URL is correct and matches the URL of your deployed Azure OpenAI service. Think of it as making sure you have the right address for your AI model. Correct the endpoint URL to match the URL of your deployed Azure OpenAI service. A langchain session that hasn't been properly initialized can lead to errors and prevent the chatbot from functioning correctly. To address this, review your langchain code to ensure that the session is initialized correctly. Think of it as ensuring that the conductor is ready to start the orchestra. Review and correct the langchain code to initialize the session correctly. The chat history might not be stored properly, leading to context issues and inconsistent responses. To fix this, implement a reliable method for storing the chat history, such as using a database or a dedicated file. Think of it as providing the chatbot with a reliable memory system. Implement a robust system for storing the chat history, ensuring that previous interactions are preserved and accessible. The chatbot's response might be poorly formatted, making it difficult for the user to understand. To address this, refine the response formatting logic to produce a clear and organized output. Think of it as polishing the final product to ensure that it is both informative and visually appealing. Refine the response formatting logic to ensure that the chatbot's output is well structured and user-friendly. Remote file metadata. Remote file metadata, a tool that retrieves metadata information about a remote file stored in Azure Blob Storage. This tool provides insights into the file's properties, including its size, type, and last modified date. without downloading the entire file. This is particularly useful for applications that require quick information about files without needing to download them. For instance, a content management system might use this tool to display file details to users without fetching the whole file, while a data analysis pipeline could use it to filter files based on their metadata before downloading them. Inputs: the URL of the remote file stored in Azure Blob Storage. This URL is a unique identifier for the file, allowing the tool to locate and access it. A typical file URL might look like this: https account name, blob, core, Windows, net container name file. Name. This URL should be accessible to the tool for proper execution. The path of the remote file within the Azure Blob Storage container. The file path is relative to the container root and specifies the location of the file within the container's hierarchical structure. For example, a file path could be folder-subfolder file.txt, indicating that the file is located within the folder and subfolder directories within the container. Outputs: a dictionary containing various metadata attributes of the file. This dictionary provides information such as the file size in bytes, type e.g., text plain, image JPEG, last modified timestamp, and other relevant details. This metadata allows developers to programmatically analyze and utilize the file's properties without having to access its contents directly. Steps: retrieving the file URL from the provided input. This ensures that the tool has the correct location of the file in Azure Blob Storage. Calling the Azure Blob Storage Application Programming Interface API with the provided file URL and other necessary parameters. This step involves interacting with Azure's infrastructure to access the file metadata and retrieve the required information. Prerequisites: an Azure storage account is necessary for storing and managing files in Azure Blob Storage. This account provides the infrastructure for storing, accessing, and managing files in a cloud environment. It can be created through the Azure portal or using the Azure CLI. And it comes with various features and configurations, such as storage tiers, access controls, and replication options. An Azure storage account with a container serves as a dedicated space within Azure Blob Storage, where the remote file is stored. The container is a logical grouping of files, allowing for better organization and management of data within the storage account. Containers can be created within the storage account using the Azure portal or CLI, and they can be configured with various access policies and storage options. An Azure storage account key is essential for authenticating and authorizing access to the Azure storage account. This key acts as a password, allowing the tool to securely interact with the account and retrieve the necessary information. The account key can be found in the Azure portal under the Accounts Access Keys section. Fine-tune parameters. There are no fine-tuning parameters required for this tool. The tool operates with the provided inputs and prerequisites without any need for additional configuration. Challenges and fixes. An invalid URL might be provided as input, preventing the tool from locating the remote file. In such cases, carefully review the URL to ensure that it is correctly formatted and points to the intended file. In Azure Blob Storage, the Azure storage account key might not have the necessary permissions to access the file, resulting in an unauthorized access error. To resolve this, ensure that the account key has appropriate read permissions for the specific file and container within the storage account. This might involve reviewing the account's access policies or granting explicit permissions for the tool to access the file. Langchain Chroma vector stores cosine similarity summary. This document details the process of calculating the cosine similarity between two embeddings using the chroma vector store. Cosine similarity is a measure of the similarity between two non-zero vectors. It is calculated by dividing the dot product of the two vectors by the product of their magnitudes. This approach can be applied to measure similarity between documents, queries, or any data represented as embeddings. Inputs: a vector representation of the query. This vector usually represents the semantic meaning of the query. The vector embedding stored in the chroma vector store representing a particular item. Outputs: a numerical value between 0 and 1. This score represents the cosine similarity between the two embeddings, with 1 indicating perfect similarity and 0 indicating no similarity. Steps: retrieve the query embedding. This step typically involves utilizing a pre-trained embedding model to generate the vector representation of the query. Fetch the embedding from the chroma vector store that corresponds to the relevant item. Calculate the cosine similarity using the dot product of the two embeddings. This involves multiplying the corresponding elements of the two vectors and summing up resulting products. Prerequisites: a chroma vector store is a database that stores and manages embeddings. It's essential to have a chroma vector store populated with relevant embeddings. Example: a chroma vector store containing embeddings of product descriptions can be used to find similar products based on user queries. A query embedding is a vector representation of the user's query. This embedding is crucial for comparing the query to the embeddings in the vector store. Example: a user query "best running shoes" can be converted into a query embedding for comparison against embeddings of different shoe descriptions. Fine-tune parameters. There are no specific fine-tuning parameters required for this process. Challenges and fixes. If the chroma vector store is empty, there will be no embeddings to compare the query embedding to. Solution: ensure that the chroma vector store is populated with relevant embeddings before running the similarity calculation. An invalid query embedding might not accurately represent the user's query, leading to incorrect similarity results. Solution: use a reliable embedding model and ensure the query embedding is correctly generated for the desired context. Numerical issues such as overflows or underflows can arise during the cosine similarity calculation. Solution: check the values of the embeddings and use appropriate numerical techniques to handle potential issues.